Okay, so again we're going to go through sine law ambiguous case, and these are kind of templates of what our ambiguous case can be. They aren't drawn the scale, it's just to get an idea when you're only given 3 pieces of information of what you may be drawing. So we have here side A. Side A is going to be opposite of angle A. We know angle A is 36 degrees. Opposite of it is 5. 50, 5.0. Side B in this case is 8.5. Okay, so this 8.5 here. Now with this question, because they've given us these two and not the angle in between, this actually doesn't become as ambiguous. Okay, reason being, let's take a look here. Angle A in this case will obviously have to be the acute angle. So let's say we change the way this triangle looks a little. We'll try to get it a little more to scale. If this angle here is going to be 36, it's going to be our A. Opposite of it is still 5. It doesn't change whether the angle's coming. Oh yes, no it can. This one here can change. It can be coming much more like this. That's right. Sorry. Just wanted to make sure we had the right idea here. And our side B, we said, was our 8.5. Yeah, that's right. Okay, so we may have a triangle set up like this down here. That was incorrect before. We have a triangle set up like this. So we have our 36, our 5, sorry, 8.5 and our 5. And then again, we have our 5, 8.5, and 36. We don't know which of the two triangles we're really setting up here, right? So what we're going to do is plug them into our sine law and work it out to figure out our other sides. Now, we do want to find side C, but since we've already kind of went through this once, we know that in order to do that, we're actually going to have to solve for at least angle B first, right? Because the only information we have is we have the entire ratio for A. We have the side and the angle in both triangle 1 and triangle 2. And we have the side for B, but we have no information on C. So once we find a second angle, we can deduce a third one because we know triangles will add up to 180. So our sine A will be sine 36 divided by 5 is equal to sine B, which is our unknown, divided by 8.5. And sine C can kind of drop off. We don't need it for this case. We then cross multiply, like we've done before, 8.5 times sine 36, scroll down a bit, divided by the value of 5 is equal to sine B. And then because we're finding angle B, we actually want to find the inverse of sine with all of this in one bracket. Sine 36. What did you get as an angle in this case?
87.7.
87.7. Okay, so our angle B here, 87.7. Okay, now this one looks odd for it to be, well actually no, here's our, it is an acute angle, though it's not really drawn to scale. This makes sense. We have an acute angle, and this is acute, is less than 90. So we can easily find out angle C for this one here. We're just going to take the 180 and subtract 87.7 and 36 from it. And what will we be left with?
56.3.
56.3. Great. Okay, so this is 56.3. That makes sense. But in our other case here, our angle B happens to be an obtuse angle. So in other words, what we've actually found, and we'll just extend this a bit, okay? Because this is an obtuse angle, what we found here is this is our 87.7. So we got to subtract it from 180 to find out what this obtuse angle is. And then from there we subtract 180 again from our information to find out what angle C is. So first step, we'll do it in purple, I guess, to find out this actual, or sorry, blue, find out this angle. So we'll go 180, subtract our 87.7. And do you know why we subtract 180?
Yeah.
Because this whole thing here, yeah, is 180. Take our calculator here.
93.3.
Yeah. So we get 93.3, that's right. And that makes sense because that is an obtuse angle. So because that works now, we can now subtract the two values from 180 that are inside the triangle. So we subtract our 93.3 and our 36. And that's like a 6. Less than that, maybe around 50. What do you get when you subtract those?
50.7.
Yeah, makes sense. 50.7. So angle C in this case is 50.7. So now we're working with two different types of triangles because of those angles. Because of those angles, this angle here is larger and this one's a little smaller in comparison to each other, which means this side C in triangle 1 will be a larger value because a larger angle is opposite than in triangle 2. So we're going to have to work out two different versions of it now with our sine law. So we'll go down and we'll kind of put a split page here. And in one version, the information we have was angle A, pull them all together here, it was 36, B is 87, 36, angle B is 87.7, and angle C in this version was 56.6 maybe, or 0.3, there we go. And our other version, we'll do in blue, A and B are still the same. It's just our angle C that's different, 87.7. Angle C we said was 50.7. There you go, 50.7. Okay. And our side lengths are still the same. So when we use our sine law here, we're going to get sine. Angle A is 36. I'm just going to put the whole thing out here. Side A, let's get these. Side A was 5 and side B was 8. So 5. B is 8.5, yeah. So A is 5, sine B is 87.7, and a 5. And I'm going to show you a trick here. We have sine C is actually 56.3, but side C is what we're looking for. Okay, now we can work from here. There's nothing wrong with that. And what we'll do is in the first one, I'll actually show you how to work from here. We can choose either of these ratios to work with. Whether it's this ratio, we pair it up with the one we're unknown, or this one, we'll still end up with the same answer. I'm just going to use the one in the closest vicinity, so we'll kind of cut out our A values here. In order to do this, I can quickly cross multiply to get rid of our idea of fractions, right? So, let's put this down. We'll then have C multiplied by sine 87.7 is equal to sine 56.3 times 8.5. And then we'll just get C is equal to sine, I'm going to type this all in, 56.3 times 8.5, all divided by sine 87.7. And that'll give us our C value on the one hand. So while you calculate that, what I'm going to do is I'm going to set up the other one. Same idea. But because sine law is a ratio, I can flip everything. So I'm actually going to put the sides on top. We have 5 over sine 36 is equal to 8.5 over sine 87.7, and C over sine 56.3. What did you get for an answer down here?
7.08.
7.08. Okay, that makes sense. Centimeters for that one. Now, in the second one here, this was our second triangle, I flipped the ratio compared to this one over here. And that's fine, because of ratios, as long as I flip everything, that's great. And what we can do now, it'll make it essentially one less step. See, here we had to cross multiply, and then I had to bring over this value on the other side. When the C's already here, and we kind of pair it off like we did, the only step will be to bring over this bottom, and then we'll be looking for C right away. So in one move, by just flipping that ratio, I essentially solve or save myself one line of writing algebraically, you could say. Okay, divided by sine 87.7. Oh, sorry. I wrote the same angle value here, but this is a different triangle. Remember, this was 50.7. Make sure we get that right. 2.7. Okay, because this was our triangle 2 we were talking about. So in this case, that'll give us a different measurement for side C.
Mm-hmm.
Did you get a value?
6.58.
Yeah, that makes sense, right? If this value is less than this one here because it's opposite of an angle, that is smaller than the other one in the ambiguous case. Okay, so quite a bit of work sometimes when going through